Thank you. So what we're here to talk about today is something that causes a lot of people problems, which is I've got people all over the place, I've got systems and storage all over the place, and I need to make them all work together. And the LAN and the WAN are totally different environments. If I'm on WAN access, it's a different experience than if I'm on LAN access. And so what happens is the people at the headquarters where all the data is, they have great access. They have fast opens to their Autodesk. They have fast opens to all of their virtual desktop environments, and everything's great, except when you go out in the sticks and you're over the WAN links with latency and slower bandwidth and outages, it's not so nice. Sometimes things don't even work. We have customers, we're an Autodesk partner as well, where some of the design packages just don't work with a certain amount of latency. And so one of the solutions to that is to get a distributed file system, a file system that actually mitigates the WAN and makes the WAN's impact lessen or, in many cases, go away. And the way to do that is to get the data to the user and let the little things go over the network, not the big files. And the little things include locks and changes to files. I might have a 15 megabyte file that's been replicated across the sites. If I only send over the changes, I can save a lot of that WAN traffic. And if you talk to any customer, if you talk to any organization, I can go into an implementation and say, we need to double the RAM on this server, and nobody really thinks twice about it. I can say we need to double the storage, and everybody at NetApp likes that, so that's a good thing to say. And that's something that nobody really complains about. I can double the CPU, and that's really not a complaint. But if I say I got to double the bandwidth between Sydney and New York, everyone loses their mind, because that's a really big cost. That's a really big problem. So bandwidth is the last frontier, and we're here to fight that frontier, okay? Because what we do is we take the data and we put it everywhere, but we also don't segregate it. We distribute it, and so we add file locking and synchronization through our products, through our suite called Global File System, GFS, and we allow you to have your cake and eat it too. You get to have the data everywhere, so you've got multiple copies, better backups, better recovery. We fail open. If something happens to our software, the copies are still accessible. We're not getting in the way of the data. And so we've been doing this for more than 20 years. This is not a startup. This is a company that's in a startup mode, but we're not new to this game. We've played the game for a long time. We've seen it all, mount points and queue trees and everything in between, and we understand the technology well. We work very well with NetApp. We work with Windows operating systems, and we can move data from pretty much anywhere where there's CIFS. Okay, so that's the overview. That's the meat of the question. What are we trying to accomplish? We're not trying to accomplish global file system for the sake of it. We're doing it because there's a problem here. And the problem is a lot of users aren't able to work because their data is too far away and the WAN is too difficult to navigate. So what is GFS? What's it made up of? Well, the core of it is the PMC, the Peer Management Center. It's a centralized, web-enabled interface that allows you to see everything that's going on. So we have some very large customers. I work a lot with the government. I'm ex-military, West Point graduate, Gulf War veteran, and so I do a lot of our military and government stuff. I'm the token Army guy. And so we have some three-letter agencies we're dealing with, and they have hundreds of sites. Now, some of that data just needs to be synchronized. And so that's where the PeerSync portion of GFS comes in. PeerSync is our replication engine, more than 20 years in service. It has options that I don't even know about. Okay, it has lots and lots of capabilities to deal with things. We had a three-letter agency put us through the ringer with this product at one point. They said, you got to replicate data with a 750 millisecond latency and 30% packet loss. And we were the only vendor that survived that. It took a week to send over the sample data, but we survived that because we're into enterprise. We understand that we're not going to deal in an idealized environment the way a lot of other companies do. Okay? So that's when you need to move data fast and furious. And let's just talk about the PeerSync aspect of this for a second. This is our fast and furious data mover. We had a customer that had 68 million files, which doesn't sound like that many files in this day and age, but they needed them moved in a weekend, like start to finish, move the data. And they kept adding millions of files a day, so it was important to get this done. And so with some tweaking, we were able to move 1.2 million 10K files per hour, which nothing else they could do. So we can scale up with threads, we can scale up with instances, so we have a lot of different options. We can be clustered, So it's a very enterprise level solution here. So PeerSync is that replication engine. And it's really well tuned for migrations. If you want to get data off of an old system onto a new shiny CDOT system, then you can use PeerSync for that job. And we can send over the permissions or not. We can send over stub files. Pretty much anything you can think of, we can handle. Okay. Now, it's also very tunable. Okay, we can decide, we have two kinds of clients that want to move data in a migration. We have those that say, my network is very fragile, don't break my network. And so we start with a very low number of threads, five job threads, 10 copy threads, and we're very conservative. We take care of the system, we don't knock it over. But we can also have customers that say, crush my network, I dare you. I have a 10 gig link, let's see what you can do. And we can tune those threads up into the hundreds. We can optimize based on using our TCP stack, or we can use SMB. SMB3 is a pretty fast protocol with if there's a low latency. So we have a lot of tools in our arsenal because we've got 20 years of experience building them. Okay? Now, that's very well suited for moving user data. User data is data that only one user is going to use. Your VDI data, your roaming home directories, profiles, that kind of stuff. But what about the collaborative data? Data that I want to open up my Excel spreadsheet and I want to make sure that you don't open up the same spreadsheet and overwrite changes and then we have to talk to each other or email each other or figure out. We don't want to lose data. That's a big, big, important prime directive for us. The prime directive is thou shalt not lose data. Okay? Because if you're familiar with database analogies, databases can be tuned for concurrency or consistency. And concurrency means that I'm going to let a lot of people access the data, so that I let people get dirty reads and I let people read things that might change under their feet. But I can also tune towards consistency. We're a consistency model. Our first commandment is don't lose the data. Okay? So the way we do this with GFS is you open up a file in LA, I try to open the file in New Hampshire or Boston, and what happens is the lock has been sent over to my site. And I get the same experience as if we were trying to access the same share. I get the note, this file is in use by, John, and do you want to be notified when that file becomes available? And if I say yes, I'll be notified and I'll be able to use the file. And so it basically takes the user out of having to care where their data is. And when we layer on top the DFS namespace capabilities that come with Windows and we configure through our interface in a coming version, then you end up having an ability for the users to just not care where their data is. It's just always there, it's always fast, it's always immediate. Okay, so that's the vision. So the PMC is like this one pane of glass. I can see both my collaboration jobs and my synchronization jobs, and I can manage them. So it doesn't matter whether I have hundreds of servers I'm synchronizing data or just a dozen or even just a few. That one interface gives me a client and a web interface. It also lets me do some administrative tasks. Like, for example, there are some instances where I might get into a situation where the network outage causes two people to be able to open the same file at the same time. Okay, we don't live in La La Land and think that can't happen. It can happen. Someone could shut off one of our agents, or there could be a hiccup with a service, and two users could get access to the same file in two different locations. But don't panic. We'll call that a conflict and we'll watch it automatically. And if one of the users closes the file, we'll then lock it quickly and we'll get it back to the status quo and we'll resolve it automatically, because that's what you want. You don't want to be managing this stuff. You only want to be notified when data is in danger. Okay? And data is not in danger until two users modify the same file and save. Okay? When that happens, it's called a quarantine. And administrators get a notification. We can do SNMP notifications, very important to some of our larger financial organizations. And we can notify someone like Help Desk, and they can come through the web interface and resolve it, or notify the users and get them involved. So this is a well thought out strategy to mitigate the most important resource in every environment, which is the WAN, which is blocking the real most important resource for every environment, which is the users. Okay, your users are actually the only thing more expensive than the WAN. Okay, those engineers, those writers or technicians, scientists, whatever the organization is, we need to get the data out of their way. And the best way to do that is give them their own copy. Storage is inexpensive these days. And that way, they're not subject to the whims of the WAN and outages and all the other things that go onto it. So how do you approach this? Well, the first thing you need to do is identify what you want where. You don't have to have everything everywhere. You can put the business shares for a certain project in one location. In fact, because of the flexibility built into the architecture, you can have organizations outside of your forest, outside of your domain completely, and have them share in this model. And the way that works is the peer agent that runs on those systems is transparent to domains. It uses a single protocol port, uses 61.61.7 with an SSL layer for security. But if you want us to not do that, if you want us to be more transparent for your WAN accelerators, we can use 61.61.6 or any port you configure. It's very configurable. Okay, so let's say I have an engineering firm, and I'm building the next convention center for Las Vegas, and I'm bringing in consulting firms left and right. I don't want them VPNing into my system. I don't want that, because there's security problems and there's people who can click on ransomware and it might end up coming to a share in my organization. I don't want that. What I want instead is I want to give them an agent and set them up in a job where that agent participates and it gets the data that's assigned to that job, the stuff they're working on, and they get a copy local to them. And when they make a change, it locks the file, it distributes that lock everywhere, and so now they're integrated in my team in really a nanosecond. It takes an hour to set this up if you're not ready, and it takes a lot less time if you are ready. Okay? So once you figure out where you want the data, you throw either PeerSync or the agents and the components. You have the PMC installed someplace central for your reporting and as a data clearinghouse, basically as a traffic cop for your interchanges. And once you've mapped that out, we normally will set up a POC in an hour if the prerequisites have been met. If they haven't, it usually takes 2 hours. Okay, very quick. All software solution, no hardware involved, and you keep your existing investment. Okay, so that's in a nutshell. And the users, they need to not know what's going on. That's the ultimate. Electricity is one of those things that's reached its stride. Users just don't care where the electricity is coming from. They plug in, they use it, they don't care. That's where we want to get to. And the GFS is getting us there because the users don't know. With DFS namespace, if you haven't played with it, unlike DFS replication, which has serious problems with scale, DFS namespace works pretty well. If I'm connected to a DFS namespace share and it becomes unavailable, typically within about 30 seconds, it'll switch over to the next share, and the user may or may not notice. They may get a hiccup where the file they're accessing, they lose a handle to it, but that's about it. Okay? And so by working with these kinds of technologies, we can make it transparent to the user. They won't even know that their data is coming from someplace, and that's what we're all after. We want the users to just get on with what they're doing and not have to be storage experts. Okay? So multi-platform is a big part of this because people have Windows servers. And that partner scenario that I just explained, you don't know what they have. They may have NetApp, they may have something else, but they almost always have Windows servers poking around. And so by being able to support both NetApp through F-policy and Windows through API calls directly to the file system, we're able to make this magic happen across platform. And for that reason, we're not block-based, we're file-based. And some people might think, well, if you're not block-based, that's slower. That's not the case. We have a customer that is a very large financial, and I work with them quite often, and they've told us that they're replicating their VDI data across 3 locations. 1 with a high latency and 2 with very fast, low latency connections. And they're able to not only get very high throughput in the replication between the sites, they're also reported to us that because of our byte replication, we only send over the parts of the files that have changed. Instead of the 6 terabytes of file changes they have a day, we're only replicating 1 terabyte of net changes amongst their sites. So their WAN is under far less stress, and again, that's a huge cost savings. In fact, in that customer alone, that's probably enough cost savings to justify the cost of our product several times over. Okay, so let's talk about NetApp and how we integrate. So we integrate both the PeerSync components and the peer agent components integrate with F-policy. And if you're familiar with F-policy, it's an interface that NetApp developed to allow companies like us to do our operations without installing on the box. Very important, very powerful, and very problematic in the old days, but it's gotten a lot better recently. okay? Now, we work very closely with the NetApp team, and a lot of the problems you've heard, a lot of the horror stories you hear are associated with something called synchronous. So with synchronous F policy, the subscriber to the F policy has to say yes to every request, which means they're blocking, they're in the way. We are asynchronous by default, which means they just send us the information. It's like a letter. If we get it, great. If we don't, they'll follow up, okay? But we're not in any position to block the filer, so therefore we have, once F policy is on, we have almost no impact on the performance of the filer. And that's important because you want us to not only be low impact, but we want to fail open. And I said that before, I'll say it again. If somebody decides to shut off our service or our service account goes down, I had a customer that says they change their passwords every 8 hours. So we're still trying to figure that one out. But so if something happens and we can't get our services going, we fail open. The users have a full copy of their data. And a lot of organizations are trying to foist on you the idea, well, we want all your data in the cloud and we want to have just a cache. Well, what happens when the connection goes down? Well, you're out of business. You're not working. What happens when your network just gets laggy to the internet? You're out of business. And again, bandwidth is that premium thing still. It's one of the only things that we can't get a lot more of tomorrow. Even if you had the money and you wanted to buy a new connection between Singapore and New York, good luck getting it set up for tomorrow. It's just not going to happen. And there are some places in the world where you can't buy the connectivity. There's just too many obstacles. So we're here to try to make sure that we can mitigate that WAN and make it easier for everybody to get access to their data. Thank you very much.